So the last two videos in this series on long division have focused on just the process of long division, divide, multiply, subtract, bring down, and doing a couple of homework problems that are just about doing the long division process. And we've been writing all of our answers with remainders as fractions. We did two of the even problems last time. But this time I'd like to look at why you might use long division in relationship to factoring. So I'm going to do a sample problem like 21 or 25 on your homework tonight. I won't do 21 or 25. You can do them on your own and check your answers in the back. If you're not getting them, obviously send me an email or make sure you come and see me on Monday. But the problems that are even are pretty close to those odd ones. So I think you'll get a good idea about what this process is all about. So let me scroll down here and give us a little space to work in. When we are using long division to factor, we want to end up with a remainder of 0. So we're going to be looking at remainders that are equal to 0. So basically we're not going to have a remainder. And if we have no remainder, then we know we're doing our process correctly, that we are actually splitting things up into one thing times another thing. So let's see here. We'll do 22 to start off with. Let me just get out of red. We'll do calming green. There we go, a nice calm green. That's always good to do long division by. I have a polynomial f of x equals x cubed plus 6x squared plus 5x minus 12. And I'm asked to factor that. And if I look at my factoring methods, well, boy, maybe I could do some regrouping here. Maybe that would work. I definitely can't do a greatest common factor. It's not the difference of 2 cubes. You know, all those little cute, quick factoring techniques that I've been practicing don't seem like they're likely to work here very well. So what I am going to try to do is to use long division to turn this polynomial into something that maybe might be more factorable. And the book gets me started. They suggest that I divide this polynomial by x plus 4. So they're saying divide that polynomial by x plus 4. And what they're saying really is that this is one of the factors. So this is one factor. So they're giving me a factor for free. I know that x to the 4th is going to go in evenly into x cubed plus 6x squared plus 5x minus 12. Why? Well, in this case, because the book is telling me that it should go in evenly. So let's do our long division process. So long division starts off by writing what you're dividing by on the outside of the box and what you're dividing into inside the box. So I've got x plus 4 on the outside, x cubed plus 6x squared plus 5x on the inside. I've got that same process. I'm going to divide, I'm going to multiply, I'm going to subtract, and then I'm going to bring down. So that should be pretty familiar now, especially if you've done most of those homework problems. All right, so once again, I just divide that first term, the x, into the first term under the box, the x cubed. X goes into x cubed, x squared times. So x squared times x squared. Multiply back, x squared times x is x cubed. X squared times 4 is 4x squared. Next step is to subtract. X cubed, take away x cubed, cancels. 6x squared minus 4x squared is 2x squared. Last step, bring down. So bring down the plus 5x. Repeat. X goes into 2x squared. 2x times. So plus 2x. I'm writing that over the 5x terms, so keeping like terms with like terms. Multiply 2x times x is 2x squared. 2x squared. 2x times 4 is 8x, so plus 8x. Now subtract. 2x squared, take away 2x squared, no x squared. 5x, take away 8x is negative 3x. Bring down, so I'm bringing down that negative 12, minus 12. Repeat. X goes into negative 3x now. X goes into negative 3x a negative 3 times. So minus 3, oops, minus 3, I'm putting that over the 12. Negative 3 times x is negative 3x. Negative 3 times 4 is minus 12. And now I'm going to subtract. Negative 3x minus a negative 3x cancels. Negative 12 minus a negative 12 also cancels. Yay! I have a remainder of 0 just like I thought I would, which means that x plus 4 is a factor. It's one of the factors of my x cubed plus 6x squared plus 5x minus 12. So now I can start the process of factoring here, or at least write down what I have so far. So I started off with, my original was x cubed plus 6x squared plus 5x minus 12. And then I factored that, so it became x plus 4 and x squared plus 2x minus 3. X squared plus 2x minus 3. So I factored it into those two things. Well, how do I know that's a factored? Those are factors? Well, because I divided them out of each other, and if I multiplied them back again, like if I went that times that, I would get this guy. They're both factors. If you multiply them together, you'll get what you started with. All right, so this is a good step towards factoring, but I bet you I can do a little better. Let's look. The x plus 4, that one is probably done. I'm not subtracting. I don't have cubes here. There's no greatest common factor. So x plus 4 looks done. What about the x squared plus 2x minus 3? Can I think of two things that multiply to give us negative 3 and add to give us 2? Well, let's see. Factors of negative 3 would be 1 and negative 3, or negative 1 and positive 3. Yeah, this would give us 2. So let's rewrite it. X plus 4 and x minus 1 times x plus 3. So now I've factored it again. These two new factors, could I keep going with the x minus 1? Well, I'm subtracting, but x is not squared, so I'm done with the x minus 1. X plus 3, I'm adding. I don't have cubes, so I think I am done. So let's see, f of x factored is x plus 4 times x minus 1 times x plus 3. I factored it completely. Yay, there's my answer. All right, I'm going to do one more video, I think, and I will do another one of these factoring a polynomial by using long division. So see you in the next video.